Hi everybody, my name is Tuyết. Now we continue with my paper. The title of this paper is Improving Morphology and Recurrent Residual Refinement Network to classify hypertension in retinal visual imaging. My presentation includes 6 sessions. The first session is introductions. The second session is background and the relevance. The third session is our proposed methods. The first session is experiment and our result. The next is our conclusion. And the final session, that is some reference. And now we start with the first session of presentation. This is the introductions about project. The hypertension classification based on the retinal blood pressure segmentation is one of the state-of-the-art approaches. In this slide, we can see that there are some retinal blood vessel images. They have many information of disease, such as hypertension, heart disease, diabetes, etc. The final image that is the result of segmentation. From these results, the blood had a thing from 1 to 9 pixels. With everybody, this is very small. However, with disease stratification, this is very important. Therefore, the detection and classification of hypertensive retinal image is very useful in the diagnostic of doctor. In this paper, we propose a new method for the hypertension classification based on the saliency. The saliency is the basic concept for choosing the strong area of objects in image, not only based on superficial. Many methods were proposed to classify. We can start with the transform. Each transform has 2 periods, decomposition and the reversion. In the decomposition, from the input image, divide the multi-level, and each level is applied the filters or the thresholds, such as Laplacian filters or direct filter bank. This is the result for the calculating of the covariance or the parameter for the reversion. However, transforms have many disadvantages. The first disadvantage, such as the adapting with many filters or ratios. This is my class information. And the second disadvantage, that is the time for processing environment. Another method is morphology, that is based on the mathematics or based on the step or the value of the neighbor pixel. In the recent years, the development of machine learning, of neural network, or deep learning, such as convolutional neural network, fully convolutional network, UNET, or something like that. On the other hand, the connection between physics inference system are the basic of the silent map for the deep learning. The silent map is a concept based on the superpixel. From the research, we can rule that the limitation in prediction because of the input parameter and the output layer. From the input, noise and blur value, that is creates the decreased quality of the input image. In some research, the actual tester for the saliency classification can be divided into multi-level encoder. We can call that the convolutional layer. The high-level receptive fields are the semantic information, such as its part in object, color channel, ray level in surface, and something like that. The low-level features can be adjusted as corner, orientation, The figure 1 is a popular deep learning for the silency prediction for the classification. We can see that from the input image. A popular learning model can be include 3 periods: downsampling, upsampling, the multi-output. From the input image, multi-level apply convolutional layers, and that is the input for the deconvolution in the upsampling period, and continue to the input for the silency prediction of the final period. The synthesis of all silency predictions of the final period, that is the silency combination for the classification. Based on this knowledge, we propose a new method for hypertension classification. Our methods include 3 stages. From the input is the retinal blood visual image. The first stage is the morphology. The second stage is the recurrent residual refinement network. And the final stage, that is the silency classification. In this model, morphology stage and recurrent residual refinement network are the main stage. The original morphology stage includes 7 steps, as figure 3. From the input image, the first step is choosing the channel color. Each image has 3 channel colors, that is red, green, and blue. In this paper, we chose green channels for the next step. In the second step is the CLASE. That is the summary of the contrast limited adaptive histogram visualization. The third step is the top hash transform. The next is the applying the filter. Next, binary transfers. Next is the enhancing the quality. And the final step of the morphology stage is the applying mask. This is the referring for the segmentation. However, in our model, we only use the result of steps from 1 to 9 in the original morphology methods. The adaptations of our model for silency map based on the residual refinement block. And in this model, he chose steps for the residual refinement block. From the input, we use upsample for low level and high level. Low level has 2 information. The first information is the silency map, and the second is the input for the 3 blocks of convolutional and ReLU. The final result combination with the silent map, that is the input for the second step. And the second step is similar with the structure of the first step. The silent map and the other result of the high level, that is the input for the 3 block convolutional and ReLU. And the synthesis that's on, that is the silency classification for hypertension classification. That's on the step in our model. We test in 2 datasets, either stage and right. Our datasets have 2 classes, hypertension and non-hypertension class. As a result, the final stage gives the classification about the kinds of disease in retinal blood vessels. And that is the result of the original morphology stage with 7 steps. From left to right, the first figure is the original image input. Next is the result of the showing the green channel for the next step. Next is the result of the CLASE step. Next is the result of the top hash transform. Next is the result of the applied filter for the step, and in here we apply the Gaussian filter. Next is the result of the mean C threshold step, and the final is the result of the denoising step that is preparing for the final segmentation. We compare the hypertension classification based on the accuracy of prediction and classification. The table 1 presents the evaluation of the morphology method and some deep learning model, such as convolutional neural network, fully convolutional network for the saliency classification in all datasets. We can see that the combination of the morphology method with our recurrent residual refinement network is better than others. In this table, the second column is the morphology methods, and we apply the original method with the 7 steps in the figure 3. The next column, that is the result of the morphology combined with convolutional neural network in 6 blocks. And the next column is the result of the morphologies combined with 6 blocks of the fully convolutional network methods. And the final column, that is the result of the morphology and recurrence residual refinement network. That is our model. And we can see that the report method fits with the hypertension classification. The next table, that is the evaluation of the average success index in ratios of filter step with the report method. The table 2 presents the average success index. The second column, that is the morphology for segmentation. We apply the algorithm with a 7 steps in the figure 3 for segmentation to evaluate clearly with the saliency for the classification. The third column is the result of the morphology combined with our models in testing. In two approaches, the success index based on the mean C resulting for segmentation is higher than Bayesian, median, or the Gaussian filter. So we apply mean C results for the evaluation with our model for saliency, and we compare the results of our method with the recent method. In here we combine with three methods. That is the first method that we compare is the recurrent residual refinement network for the saliency classification. In the reference with the numbers is 15. The second method for the comparison, that is the morphologies based on the feature extraction. That is the reference in the number of 17. And the final method for the comparison, that is the morphology and superpixel based on fast fuzzy mean clustering network for the saliency in the reference of 20. And the final comparison, that is presented clearly in the table 3. From this value, we can see that using the morphology for the inputs of deep learning gives a better result for the classification system. However, depending on the filters or the result for choosing the number of the input parameter, that is also a vital step. The results of the Rose Bowl method are better than the others. In this paper, we Rose Bowl a new method to improve the morphologies with a deep learning for the hypertension classification in retinal versus image. And I think that the nature of improving the quality and choosing the color channel for transform overcome the limitation of the noise detail in the learning model. So the detection and classification, that is the very important for the diagnostic of the hypertension. And we can conclude that the improving the quality and choosing the color channel for the input parameter, that is necessary. The morphology is an own approach in image segmentation. However, if it becomes one of the parameters of saliency classification and determining, the result will be better. We compare with the recent order, and we can see that our experiment results are better than others in the state and the right dataset. In the future, we want to improve the results of our model and test in other datasets. Okay, we have just go through an important point of my work. That's all, and this is some reference that we use in our research. Yes, and thank you for your listening.